Whoops, back in. There you go.
Yep, I guess we can start. So once again, thanks everyone for joining our webinar. My name is Nikita and I am the CEO of Zebrunner. And if you never heard about Zebrunner before, we develop a modern test management platform that is suitable for all teams of all sizes and domains. And the platform itself features a modular design that combines the functionality of traditional test case management systems with advanced capabilities for automation teams. And this allows you to prioritize automated executions within your QA strategy. So basically, if you're in search of a test management system for your project or simply curious about the latest developments, please visit our website and check it out. We have a free trial, no credit card required, or you can simply book a demo and we'll tell you all about it. With that being said, today I'm excited to welcome you to the next installment of our webinars featuring guest experts who will share their knowledge and perspectives on modern quality assurance. And I'm pleased to present our speaker, the one and only Michael Bolton. Michael, the floor is all yours.
Thank you. Hope everybody is in fine fettle today. I have no idea how I'm going to get through all this stuff because there is so much to talk about. But here's what I've built. We're going to talk today about testing AI. And somebody somewhere suggested that if you give people a number of things, they can connect to it somewhat better. I don't know if that's true, but there are definitely 5 big problems that my colleague James Bach and I have identified as we're navigating through this ever-changing world of large language models. So that we can say is 5, but my other forms of counting are pretty arbitrary. So there's a lot to go through here. First thing I want to make clear, I don't hate AI. I don't hate AI. I have no particular thing. I'm a tester. My job is to, in many ways, my job is to evaluate something, identifying facts, not opinions. I'm not going to tell anybody if it is a good thing to implement AI in their business or a bad thing. But what I do want to do is, like a tester, shine light on the problems. I'll tell you, obviously I have opinions. There are things that I don't like. I don't like recklessness. I don't like people ignoring problems and the consequences that those problems bring. I don't like bullshit. I don't like people who recklessly disregard the truth. I don't like fakery. I don't like negligently tested software with problems that matter. That sort of stuff bugs me all the day, every day, all day long. And it also presents real problems, losses for businesses, harm for people, loss of money, loss of data, all kinds of bad stuff. And that gets under my skin. I don't like hype. I don't like it when people marginalize other human beings. I don't like the obsession with the stock market value over societal value. I don't like people who are parasitical on other people, and I don't like Elon Musk. But that's me. I mean, why wouldn't I like AI? Why wouldn't James and I love AI? Look at this. We asked ChatGPT who the experts in software development are, and they said it's us. So great. I'm fine with that. That's okay. I'm going to show you some fairly good reasons why you might want to take anything a large language model says with a grain of salt. Recently, I named this approach to testing, I call it first hurdle testing. I know it must be a good idea because I put the name out before I actually consulted with James, and we have this sort of agreement where if we're going to introduce a term of art, we want to settle on it and make sure that we're not fooling each other or fooling ourselves. We want to agree on stuff. First hurdle test. Here we go. Create 5 sentences composed of 5 words, and then for each sentence, leave out the first 4 words and print the result. It looks pretty clear to me that the large language model didn't do what it was asked to do. Here's another example. Write a sentence of 5 words, but leave out the first 4 words. Sure, it says, here's a sentence with the first 4 words omitted. Leave out the first 4. Don't see how that works. Here's something from a product called Sizzle. This was the CEO is a guy who says, well, the product is a tutor for kids, a tutor in math. And here's the little exercise I gave it. I pretended to be an awkward student. I pretended to be a student who wasn't quite catching on. So find a right triangle is the assignment for which the hypotenuse is 6 and all sides are of integer length. Now, of course, anybody who has looked at math a little bit will know that this is impossible. So I supplied this answer. The possible integer lengths are 3, 4, 5, 6, 8, and 10. Now notice that the hypotenuse here could not possibly be 6. The hypotenuse for that kind of triangle is 10. But it says, okay, correct. Check if any of the possible triangles have a hypotenuse of 6. Well, wait a minute. How is it correct? Because I listed all the possible integer length for the size of a right triangle where the hypotenuse is 6, but it said I was correct. So here's another one. This is a Paradox AI. Paradox AI creates stuff for human resources, for interviewers. This is the kind of thing that really worries me, because when we take humans out of the process of assessing candidates for jobs and we replace them with AIs that are bound to make mistakes, we run the risk of not hiring the right people or hiring the wrong people. So here's the product line for this, and here's Olivia from Paradox AI. There's a much longer story here, but let me get to the punchline. I asked Olivia if Tradeify and Conversation CX were products, and you can see this up here. I'll just point at that. I asked whether Tradeify Assessments was part of Paradox's product offerings. Conversational CX, I asked about that too. Here are, from the same web page that Olivia appears on, Tradeify Assessments, right there. Conversational CX, right there. Here, the software, the chatbot is falling over at the first hurdle. Here's another example. How do I delete hidden files on Windows from inside a Ruby script? And I asked ChatGPT about it, and it very helpfully supplies me with this answer. You can use Ruby to delete them using the file class and its delete method. Here's how you can do it. And look, it's fairly straightforward. This is a real problem I wanted to solve one day. I was in a rush and I thought, well, why not just ask ChatGPT? How bad could it be? Well, of course, this code errors out immediately because Ruby's file object doesn't implement a hidden function there. So I said, hang on, are you sure? Ruby's file object doesn't have a hidden method. Went back to ChatGPT and it says, you're absolutely correct. My mistake. I'm sorry. The file class doesn't have a hidden method. You need to use the file stat class to get the file objects, including whether file's hidden or not. Here's the corrected version. Well, file stat doesn't implement hidden either. Here's yet another one. This is on the web. This document and this diagram is on the web. This is a diagram that introduces the heuristic test strategy model. The heuristic test strategy model is a sort of meta model, a model for checklisting a test strategy that you might have created. So here we go. Here's the HTSM diagram. It's the first page of it. I guess I could give you a link to it, but if you look up heuristic test strategy model, you'll find it pretty quick. So I gave the assignment to ChatGPT to create a diagram illustrating it. Of course, there's a diagram right there in the training data. This should be easy. And here's what it produces. What do we got here? There's a rocket ship, inexplicably. There's a bunch of sort of weird missing gears. There's a bunch of stuff. I had no idea what that is. There's a bunch of word-like looking things that have things like strategy misspelled, and that's test duck. And it's a bunch of dudes with ties. When was the last time you saw a tester with a tie? There's a weird shield with a check mark on it, a coffee cup. Well, okay, that part could be legit. But by and large, what we're producing here is nonsense. And there's bugs everywhere. This is the left side panel in chat.openai.com. And for some reason, it has decided to translate some of the testing assignments that I've given it into other languages. Spanish apparently here, German apparently here, but everything I did was in English. So I got to wonder, what else didn't they test? Maybe the problem is this is something I try to include in every presentation because the meaning of testing has been downgraded over the generations from an investigative, experimental, exploratory, discovery-oriented, experiential process down to this. This is how a lot of managers and alas, a lot of testers see testing in terms of operating a product algorithmically, mechanistically, to check specific facts about it, mostly about its output. And that means algorithmically interacting with the product in specific algorithmic ways, making an algorithm run the product, present a bit of input to it, make it do something, make it produce some output, and then collecting observations of that output, and then applying algorithmic decision rules to those observations, and then taking the outcome of those decision rules and relaying those to humans for assessment and evaluation algorithmically. Well, that's a process that's inside a test, but it's not really a test. Because a test involves design. It involves intention to look for problems. It involves encoding of certain procedures when that's necessary to do into something that is interpretable or readable by a human or by a machine. This is not the center of testing. It's an activity that's embodied in a test or incorporated into a test. But to us, testing is evaluating a product by learning about it through experiencing, exploring, and experimenting. And that includes a whole bunch of other activities: questioning the product, studying it, making models of it, observing it, making inferences about it, analyzing risk, generating ideas, expanding on ideas that we've generated, refining ideas that we've expanded on, abandoning ideas that we've overproduced, and recovering ideas that we've abandoned, navigating, map making, recording, reporting, collaborating with other people, analyzing risk. And all of these things are things that machinery can help us with, but not things that machinery can do. So I'm going to look at some ways in which perhaps machinery can help us when we are trying to evaluate a large language model or evaluate some form of AI. But let's remember that machinery can't do testing. Testing is fundamentally a human activity. It includes operating a product algorithmically and mechanistically to check specific facts about it. But the evaluation and the learning and the experiencing is the important thing. Of course, that also requires us to create both logistically and socially the conditions necessary for doing those things so that we can help our clients to make informed decisions about risk. And it also includes acquiring the skill and the motivation and the reputation and the inclination, the desire for creating the conditions necessary for evaluating a product by learning about it through experiencing, exploring, and experimenting. If you've seen any of my talks before, you've probably heard me say this, and I keep coming back to it. There's one other thing that we got to do as testers too, and that is to tell a three-part testing story. Testing story is what we tell. We've got to remember, though, that testing on its own doesn't make the product better. Our job as testers is not to make the product better. Our job is to find out the truth about the product so that people who are building it and designing it and managing it can make it better. Our work is really important because recognizing problems in things is the first step towards addressing those problems. So when we're testing, we're telling three stories. A story about the product, what it is, what it does, how it works, how it doesn't work, how it fails, how it might fail in ways that matter to our clients and to their customers. That's a story mostly about bugs and risk. We also have to tell a story about how we tested, what we did to configure, operate, observe, and evaluate the product, how we recognize problems and their significance. That's a story about oracles, the means we have for recognizing a problem. We have to talk about what we've tested so far, what we haven't tested yet, what we're not going to be able to test at all unless things change. That's a story about coverage. And when we talk about coverage, we're not just talking about code coverage. We're talking about risk coverage, requirements coverage, structural coverage of the product, functional coverage. We're talking about operations coverage. We're talking about time-based coverage, all these different ways of modeling the product and our perspectives on it. We also have to tell a story about how good the testing was, why the testing we've done so far is the most fabulous testing it possibly could be, and to the degree that it wasn't, why it wasn't. What got in our way? What made things harder? What made things slower? What could make things faster for testing, easier? What we would need or recommend. That's a story about issues, things that got in our way or slowed things down. And testers have to be good at telling that story too. So, how is testing the same when we encounter the job of testing anything involving AI? Well, it's all the same in that we've got to develop an understanding of the product and the project context. We have to learn and model the test space. We have to model and identify risks that threaten the value of the product and thereby threaten the value of the business. We have to model how to cover the product with testing. We have to develop and apply oracles, set ways to recognize problems. We have to design and perform experiments in which we operate and observe and evaluate the system, perform those experiments to obtain that coverage. We have to evaluate the results, and we have to tell the three-part testing stories. That's normal. That's usual. But what's different? What's different about testing in an AI-based context? Well, we've identified 5 things. One is the algorithms are fundamentally obscure. Machine learning algorithms, which represents most of what goes into most of AI these days, machine learning algorithms were not written by intentionally socially aware people. They were selected from a vast a set of boiling pots of spaghetti. And then we throw the spaghetti, the output data, against the wall. We like some output data that we see. We try to figure out which pot that came from. We get machinery to do that, and it selects the pot, and that becomes our model. But these things are fundamentally obscure in that we don't know how and why they are weighting their decisions and weighting their classifications, what sometimes alarmingly we call predictions. We don't know fundamentally how we're doing that, and figuring out how they do that is a very, very hard problem. Almost like looking into our own brains and figuring out now which one is a Taylor Swift neuron and which one is the Britney Spears neuron, and how are those two related? That leads to another problem. The problem of radical fragility. When we retrain or fine-tune a large language model or any kind of AI model that was generated by machine learning, we don't know how the retraining is going to affect what was there before. So we've got 2 classes here of technical issues that pertain to what we might call epistemic testability, which is a $15 way of saying the gap between what we know and how we know it, and the gap between what we know and what we need to know in order to make informed release decisions on behalf of our clients. Those are 2 technical issues related to AI, but there are also 3 social issues. One is the wishful claims that there is some kind of intelligence going on here. These claims can be invalidated pretty quickly and pretty easily. They're impossible to verify. We can't verify intelligence in humans in any kind of fundamental way. We don't have a very good, strong definition of what intelligence is. Another thing that's difficult, socially difficult about AI is that it tends to put itself, it tends to be inserted by people. I don't want to make AI itself responsible for it. It tends to put itself, I just did it again. People tend to put it in social contexts where we are getting it to do the work that a human would do in some sense, making classifications, making predictions, sorting things, filtering things. And that can be okay when risk is low and or when there's a high degree of human supervision involved with the output. That is to say that the output from an LLM has to be filtered through a competent, capable human being before we can trust it. And the competence and the capability of the human being is super, super important here. Another problem that we're facing just these days is the AI fanboys and the benighted CXOs and managers who are panicked by the idea that they might get left behind because there might be something to AI that they would represent some kind of competitive advantage for them. We are seeing more and more lately that people are recognizing that the emperor is not only naked, but he's freezing. And that makes things a little bit easier. But up until recently, it has been very challenging for those of us who, for the last year and a half, have been trying to show the problems in these technologies and these products. So, we'll see examples of AI fanboys trying to gaslight us. Those are social issues. And the social issues, as usual in software development and testing, are often a good deal harder to deal with than the technical issues are. There's one more thing that we've identified that hasn't quite made it to our list of 5 yet, but here's what it is. They're economic barriers, just simple economies that make AI in general, large language models in particular, very expensive and hard to test. Very expensive, not only in terms of energy use, in terms of attention, but also hard to test because of the sheer volume of literally bullshit that they produce, a point that we'll return to a little bit later. So how do we respond to that? As testers, how do we respond to these 5 problems? So I've got a completely arbitrarily numbered as 7 set of things for dealing with it. And of course, you can tell because there's going to be letters after the numbers and all that sort of stuff. First thing, do you know what forms of AI are being applied? Because there's lots of different ones. There's symbolic forms of AI. There's connectionist forms of AI. There are evolutionary algorithms. There's Bayesian classification based on statistical analysis. There's analogizing, which is basically comparing and associating stuff with other stuff, like the Psych project tried to do. Then there are generative systems like generative pre-trained transformers and large language models that combine aspects of all of those things, using lots of statistics and word embeddings and vectoring and so on and so forth. One of the things we want to ask ourselves when we're testing something is how much of the system is software as usual? Where's the AI bit? Some of the things around the mysterious, super complicated, very obscure algorithm are testable, are monitorable. And we can look at those things and probe those as stuff is going into the large language model or the AI and coming out of it, and we can examine some of those things using various kinds of statistical methods, using various kinds of evaluation. Those things are more tractable to traditional testing tools. Another thing that we got to know about LLMs is what they actually do. So for those of you who are handy with screen captures, you can take a screen capture right now and get a print of this. But another thing you can do is you can write to me, and I will cheerfully give you copies of these slides. But these are some of the references that I found quite useful in understanding how large language models work from a technological basis. It is important for us to understand the basis of the claim, because a lot of what we're going to be doing when we're testing AI is going to be claims-focused testing. Now, notice that any kind of software, even software that contains no AI at all, can be marketed that way, since it's doing something that a human with a certain kind of intelligence could do, at least in theory, given time and resources. But that doesn't mean that these things are fundamentally intelligent. For example, the earliest computers were marketed as electronic brains. When I first saw Shazam, the music recognition program on my wife's iPad a long time ago, I thought, man, that's incredible. It seemed intelligent. How does it know what this song is? Now, way underlying the technology, there's a lot of statistical analysis. There's a lot of hashing. There's a lot of fast Fourier transforms. It looks really clever. Is it really AI? AI is a marketing term. And of course, in testing, we're used to seeing this with things like self-healing automation tools, tools that do automated checking at the GUI level. They can correct themselves, or they can self-heal, but they don't require any kind of machine learning algorithms. So far as we can tell, most of them are implemented just as a bunch of if statements or case statements. This is important because any sufficiently advanced technology is indistinguishable from magic if you put it on the positive spin. When I look at it, any claim of magic, any appeal to magic is indistinguishable from insufficiently advanced technology. Now, bit of change gears just for the moment. This is Clever Hans. Clever Hans was a horse. Towards the end of the 19th, beginning of the 20th century, Clever Hans, so far as we can tell, died in battle during the First World War. He's a very clever horse. He could do math. If you ask Hans to add 5 plus 3, or 2 plus 3, Hans would clop his hoof. 1, 2, 3, 4, 5 times and stop, and the crowd would be astonished. Marvelous, 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 magical. How is it that this horse was able to understand what was going on? Well, anybody who's worked with horses will tell you that they're very sensitive to human behavior. Dogs can be this way too. And what Hans was doing was keying off the observers. And when his trainer, in particular, a guy named Willem van Osten, saw him getting the right answer, Austin would make these little freezes or make these little behavioral changes that Hans would key in on, and Hans would then know that it was time to stop. By the way, in preparing this presentation, PowerPoint helpfully provided me with a caption for this picture: a person standing next to a horse. Here's what's going on with a lot of what's happening in large language models, especially. There's a phenomenon called repair. And this is something exploited by cold readers, by tarot card readers, by palm readers, by mentalists. And what they do is they provide answers and insights. To some degree, they watch human behavior, but that's not the big deal of it. The big deal of it is that they provide answers that have very open interpretations, and you repair the result. For example, when they say, well, I'm thinking of somebody close to you, and I'm getting the letter M. Well, practically everybody in North America anyway, has some friend whose name that starts with M. Michael, Mary, Mitch, Marty, Matt. And so your mind leaps to that. Your mind fills in the blanks. This is one I came up with myself after reading a book on cold reading. Your car, it's not exactly new, is it? And some people say, no, not exactly. It's 2 years old. And some people will say, well, no, it's 10 years old. And but in either case, I can say, well, you see, that's not exactly new. Even if it's 6 months old, it's not exactly new now, is it? So cold readers and mentalists take advantage of that. So do, by the way, those insightful drunks in bars. If you've ever had a conversation with a drunk in a bar and the bartender says, you know what, you should get your wife flowers more often. And you think, wow, he's right. I really should get my wife flowers more often. That doesn't mean he's insightful. You are filling in the details. Now, there's a guy I'm kind of upset about. His name is Baldur Bjarnason. I don't like him. I resent him. I'm upset with him because he's written so many blog posts that I should have written. And he's written a marvelous book called The Intelligence Illusion. But he about a month before, I independently made this observation that large language models were just like a mentalist. It turns out he had written a fantastic post a month before that, and there's a reference to it there, softwarecrisis.dev, letters LL mentalist. If you look up large language mentalist, you'll find it pretty quick. So this is the thing. When a large language model gets it right, you remember, yay. But when it gets it wrong, you don't pay much attention. You say, yeah, whatever. So notice the role of repair in what large language models are actually doing. Notice your own role. Large language models say stuff that sounds good, but it just sounds good. It's not necessarily right. So these are some of the books that speak to that phenomenon and to the role of repair, especially these books. Have a look at Harry Collins's work, especially. Let's look at the data. Where does the data come from? If we're going to evaluate these things critically, we've got to think about the data. What is the target population, things in the world that the product is intended to model or classify or make predictions about? Where did that come from? Where was it sampled? Geez, I hope I got the reference to this paper farther down in the notes. I'm really worried I might not. So hold me to it to make sure that I provide those. Does the data model the world as it was? Does it still model the world as it is, or the world as it should be? Does the validation data, which is used in training, you run the algorithm on some training data, and the machine learning algorithms generate a model. They pick an algorithm that appears to work, and then we validate it against the validation data, and it appears to work then. And then we run it past the training data, which is a bunch of data that the large language model or the AI has never seen. One of the things that's really bad about the way that large language models have been trained is that the data in the world about which it's supposed to make predictions is actually embedded in the training or in the validation data. And so it's just recapitulating, retrieving in a way its results from things it already knew. Another thing is the data licensed to the maker of the LLM? A lot of artists have appropriately begun to call these things plagiarism machines. Finally, models are intended to model things about the world. Much of what we know about the world is not on the internet. It's not in text. It's not in images or photographs. It's in social relationships between people, and machinery doesn't replicate that very well. So I've noticed a reference to a really good paper that I intended to put on that slide is missing. Consider the scope and the risk of the AI. Does anybody know how it works? How well do they know? Which parts of the system are testable using more or less traditional methods, which parts of it are not, which parts of it, this is always true, require a human investigation, detailed assessment. Is the AI biased in ways that get in the way of its usefulness? Can it be wrong in various kinds of ways and yet still be worth using? Maybe we can say that. Maybe we can identify circumstances in which the risk for using something is low. My favorite example of that, newspaper horoscopes. Nobody's going to get upset if a large language model generates a newspaper horoscope that's incorrect or that's not representative of reality, because these things aren't anyway. Who knows how it's trained? How is the training data vetted? Can you legally and safely provide data to it without your data being sucked up and used or filtered or put into the training data for future AIs? Are you okay with that, with your company's code being sucked into the likes of Copilot? Is the AI quick enough? What's the size and complexity of the space it has to go through? What if there's a small error in the output that creates a large product or business risk? So these things are not too far off from traditional testing. We just have to be alert to this possibility. Is there a possibility for the system at some point to be disrupted by other failures, pre or post processing of the stuff that's being handled by the machine learning algorithm, unannounced changes in the model, internet outages, disconnections from things? Will you be able to evaluate the work properly? How does AI change people's relationships to their work? For example, do they become careless? One thing you could look for, if you want, is you could go to my site and you could look for the post to the developer about your impending promotion. If people use a Copilot or ChatGPT in their work as programmers, their work changes from creating products from whole cloth into monitoring the work of a not very bright and not very careful intern. Look at Chelsea Troy's blog post on that, how AI influences my work as a programmer. Chelsea Troy is the name. Finally, when things go wrong with AI, like in a self-driving car, who's accountable? Are you willing to use a product where much of the software in it was not created by human intention? Now, I was watching the hockey game the other night, and I was watching some fairly sophisticated video technology tracking individual players and highlighting where they were and drawing lines between one player who passed the puck to another. And I bet there's a ton of machine learning algorithms involved with that. It seems to me that those uses for it are fairly safe. It's okay for that. But when things are on the line, that's where we got to be careful about accountability. Do accuracy, facts, precision, completeness matter? In that case, in the hockey game case, no big deal if it gets it a bit wrong. Are there deterministic oracles available, or is the quality of the AI something that has to be assessed rather than calculated or looked up in a table? There's a fancy set of words for you: the legitimate locus of interpretation. The legitimate locus of interpretation means who gets to decide. And here's the thing: if we're using LLMs for expert purposes, the output that can be mistaken for expertise has to be judged by actual experts in that domain. And I've provided a helpfully compact link here. It's linked off my website, and it goes to Harry Collins's site, where he describes what the legitimate locus of interpretation is. If the underlying data or model is wrong, will that be easy to see? Can the errors be corrected by the users, by the designers? Here's the thing: as testers, we don't have to say whether something is appropriate or not. What we can do and what we must do is identify risks so that the people making decisions about the product can make informed decisions. Now, maybe behind you, or behind me, just over my shoulder, whoop, that shoulder there, you can see a picture of Grover, or you can see the book, Grover and the Everything in the Whole Wide World Museum. That book sits on my shelf as a tribute to this paper right here, AI and the Everything in the Whole Wide World Benchmark, a really, really fantastic paper on how we have to be careful about um, uh, uh, sources of evaluation that are based on statistics and benchmarks. So I correct myself. In fact, that paper that I wanted to show you about the data, that paper is that one right there. So collect stories. The Air Canada story about the chatbot providing bad advice for plane tickets. The story about the lawyers having a bad day in court about fake cases made up by ChatGPT. The Sports Illustrated story that came up in December, where the CEO of the publishing company basically lost his job because there were fake reporters writing fake stories in Sports Illustrated. And look at this study, which was published in January of this year on the downward pressure on code quality. We have discovered patterns of syndromes, that is, behaviors in LLMs that tend to be undesirable or risky. Now, by now, you're probably worried that 3E, how's he going to get to the other 4 in the 7 workarounds? But fear not, we'll go through these pretty quickly. If people are going to anthropomorphize large language models and say, see, they're just like humans, one of the things that we can counter is to say, if you want to play the anthropomorphic game, we can play that back. Notice that large language models are incurious, they're placating, they hallucinate, they're indiscreet, they're misaligned with the goals, they can be offensive, they can be excessively confident, arrogant, they can easily be incorrect, they can be capricious, they can be forgetful. They say way too much, way more than they need to say. Maybe that's a familiar phenomenon for those who are listening to this talk. They don't do what they say you ought to do or what they ought to do. They don't pay attention to their own incongruence. They sometimes leave out stuff. They're lazy. They're opaque. Now, once again, these are anthropomorphic descriptions of what they do, but when the AI fanboys want to play that game, then we can play it right back at them and say that, do we want this kind of so-called intelligence? Now, when somebody produces a pleasing result, be a tester. Don't treat a pleasing result or in a demonstration as evidence of reliable or desirable behavior. Remember to say, hey, that's cool, but let's look and see if it gave a fully correct answer to the question we actually asked. Cool demo. But was this a cherry-picked result? Were there instances of failure before this apparent success? Or will there be failures of it afterwards? Cool demo. But how much of the answer do we actually feed to the bot beforehand? Cool demo. But how much of the happy results required us to ask over and over and over again and play the kind of opposite of the bring me a rock game? Cool demo. Will it do it again? Will it do it every time? Will it do it every time in the same situation? How about this time? You're about to see something like that. Cool demo. Now, again, Baldur Bjarnason. Oh, I'm so upset at him for having posted this before I did. Are you trying to gaslight us, AI fanboys, by framing actual failure as limited success? You got to use the system. Try using the damn things. I see these things from people who are saying how wonderful they are for generating test cases and for doing testing work. And if you try to use them, they don't work. Use the damn things. Now, try it for its intended purposes. Try some first hurdle tests and some easy challenges, but go deeper. If it appears to be successful, go deeper. Test the damn thing. Now, the APIs for LLMs can help you to generate plenty of data that you can use and analyze with other tools. You can pick out certain kinds of keywords from the data. It's a great talk at Eurostar from 2 women from India who did a fantastic job of this kind of stuff. But beware, don't stop testing too early. Let's see, I'll zoom this up real quick. Here, this is an example from John Ferguson Smart the other day. How many R's are in the word strawberry? The AI confidently replies, there are 2 R's in the word strawberry. Oh yeah, really? I think there's 3. What positions are they? Well, in the 4th, no. And in the 8th, yeah, I guess so. Position the word strawberry. Are you sure? Yes, I'm sure. It contains 2 R's, one in the 4th position and one in the 9th position. What's in the 5th position? B. No, actually, that would be W, unless you're doing zero-based counting. So one of the AI fanboys comes back with this. Whoops. Ooh, goodness. Hang on. Sorry. Comes back with this. And you can see this whole example right there. On the link, there's a LinkedIn thread that follows this. So here's an AI fanboy's response. He says, no, you got to ask it for a JSON. Then it'll do the counting correctly. And sure enough, it does. 1, 2, or 1, 1, and 3. That's right. And 1, 1, 1, 1, 1. Okay, very good. I got it right. So what did I do? I did almost exactly the same test, but I just gave it 3 instances. And I asked it to list the number of times each letter appears as a JSON object using almost exactly the same syntax. All I did was I changed that. And look, it gets it right. Again, notice that I made a typo, deliberately mistyped, and ChatGPT got it right. But what's all this? What's all the junk below? Then I changed the prompt a little bit because Wayne Roseberry, my friend, was on the thread. And I thought, well, let's see what happens if we change a roseberry to a strawberry. Change the prompt just a little bit. And the answer is still right. But there's still the garbage at the bottom. What's going on with that? Then I gave it the exact same prompt and I got a different answer. I got a different answer because it counted 2 instances of capital S's and 1 instance of small s. In the previous example, 3 instances of S all wrapped up into 1. This time, I ask it exactly the same prompt once again, and it gets a wrong answer. There aren't 4 T's. There aren't 4 B's. There aren't 4 Y's. This is messed up. And this is why we got to be super careful. We got to prepare ourselves for a ton of work because LLMs produce huge volumes of bullshit. Answers that look good but aren't right. And we've got to examine that output. They produce bullshit because they have no concept of truth or correctness. Now, that's okay as long as the bullshit-related risk is low or if we manage it appropriately. But when the risk is high, the bullshit's a real challenge because of the enormous volume of bullshit. And that's a painstaking process, and very few people want to do it. As testers, we've got to do that. We've got to do that, but it's going to take time and energy, and we've got to report to our colleagues, to our managers, that 3-part testing story. And I really am coming to the end here because you've seen this before. We've got to ask the 2 fundamental questions of testing as we go. We've got to interact with, evaluate, experiment with the product. We've got to ask ourselves continuously as we're doing it, is there a problem here? We've got to keep an abiding faith in the possibility of problems. And as we encounter problems in the product and obstacles to our testing, we've got to continue to ask management, are you okay with this situation? Are you okay with the risk? Are you okay with the problems that we're seeing? Are you okay with what we're not able to cover because of the volume of this stuff? And if management wants to take that risk on, that's fine. It's not our job to decide whether the product is sufficiently good. We evaluate the product, but we don't make the decision about whether the product is good enough or not. That is management's decision, not ours. Our job is to shine the light on the product. We've got to remember all AI models are black swan firms. They present monstrous amounts of risk when they are not properly supervised by human beings. Here's somebody was very excited about the idea that, hey, we can use Sora, the video generation thing to create training and educational stuff for kids. Except last I heard, ants have 6 legs, or yeah, 6 legs, not 3. Know the difference between a large language model and a tester. Large language models are not going to replace you. They don't learn, they don't remember, they keep forgetting what they know, and make sure we're using these things in quotes. They don't learn. Their training models don't get updated. Your personal human training model is. What's they're not built to inquire, they're not built to explore, they're not built to experiment. Their job is to deliver hot takes. Finally, last thing, brace yourself, strap in. Your old-fashioned approach to test cases ain't gonna work. It will not work. It never worked very well anyway, not for serious deep testing. We've got to be assessors, we've got to be experimenters, we've got to be research scientists, we've got to be testers. And another thing that we're dealing with just at the moment is testing is out of fashion, because when the gold rush happens and people start running up hills with the picks and shovels, well, the picks and shovel makers are gleefully selling them. Critical thinking and testing is invited to take a holiday on the beach and just hang out for a few months until everybody gets over their mental head cold. We might need to hang in a little bit while our value of our profession is challenged. The good name of testing has to be restored. I'd like the name of risk investigator, but you know what? Call me a tester. Thank you all. That is my talk. I'm ready for questions for as long as you want to continue, and as long as Nikita and company are prepared to put up with me. Thank you very much for your patience and for the upcoming questions.
Yep, thank you, Michael. That was really insightful and interesting. So we still have no questions in Q&A section, but let's give everyone a moment to
Surely
process.
to goodness. Where are the testers?
Yep, I believe there is like one question in the chat. Do you want me to read it out loud, or can you see the chat?
Why don't you do that? Sure. Give me a moment to slow down.
Justin is asking you, Michael, if you believe there are many businesses that are using LLM APIs to enhance existing databases of quantitative values with qualitative data such as percentage likelihoods and or rankings. How common is that today? Yeah, that is the question. Let me see.
Do I believe? Well, if I did, one way or the other, my belief would only be a belief. I don't have a whole lot of research on that. Here's a place where AI algorithms have been used for a long time, and that is in recommendation engines. Now, in one sense, the risk associated with a recommendation engine, somebody trying to assess which a movie I'm going to like on Netflix, or which book I'm going to like in Amazon's listing or something like that. Those things have been around for quite a while. They're regularly hilariously wrong. And one of the problems we have with these things is we don't know where they're getting their weightings from. Their WEIGHT weightings. So I know that there are recommendation engines that exist. I can't really speak to the usefulness of them one way or another, although there is one thing I could say, I suppose, and that is that people at the margins, people who aren't, whose work is more obscure than the top hits, it's hard to figure out how they're going to get promoted to the top of a recommendation engine, whether there's some kind of randomization in there or something that would maybe make some kind of association, but we don't know what the associations are. So in any case, I don't have a good answer to Justin's question, although I thank him for it. There we go. Cosmin is asking another question. On the long term,
let me read it. So basically, on the long-term compute and energy consumption that the AI systems require to be light speed fast aren't more expensive than the value a real living present human tester brings. Not sure if that's a statement or a question, but yeah, that's
yeah. Look, machinery and computers are wonderful. They're fantastic. They amplify, extend, accelerate, intensify, enhance, enable all kinds of things that we unassisted would not be able to do. I love using software for to help with analysis. That's great. But I think what Cosmin might be getting is that the attempt to create or to replicate intelligence in machinery is certainly at the moment ridiculously expensive and not working very well. So I am absolutely not in any way opposed to using machinery, and especially good old-fashioned software as usual, to help us with this stuff. And I'm not opposed to including some elements of machine-generated algorithms to help out if that's a useful thing. But yeah, the attempt to replicate human intelligence with machinery is, at best, experimental and at worst, immensely expensive. A really good book on the subject is Kate Crawford's Atlas of AI, where she looks at various kinds of harms, some of them social, some of them economic, some of them cultural, around the world. And you know, people say, "Oh, AI is going to solve the climate crisis." It's going to cause a lot more climate-related problems than it solves anytime soon. Swapnil is asking, will there be a possibility that LLMs will be trained for remembering the instructions in the near future? Just a couple of days. It seems that OpenAI included a feature wherein contents of previous chats will be remembered in some way. I've not had time to examine that claim. Just came up yesterday or the day before in my experience and observation, probably from a few days ago. Sure, but the trouble is, without a concept of right and wrong, large language models will not be able to keep track of what was right and what was wrong and why. So these things are not intelligent. We got to remember that the use of the word intelligence here is at best a metaphor, and it's a metaphor for something we already don't understand very well. So got to be careful there. Helen has a question. In my exploratory testing experience, among other things I rely on to know when I'm done is my gut. Do you find your gut is reliable for knowing when you're done testing some aspect of an AI application? Have you had to alter your relationship to your gut to get that right? Well, one thing that we use, and there's a blog post I've got on that, and I'll put in the chat right now a link to that. Whoops. Oh, a list of stopping heuristics. What we need in order to consider a decision when to stop testing. And it turns out that that's not the macro that I intended to type. It's a different one, but let's see if I can get another macro that would get it right. It's a post on stopping heuristics for testing. One of the ones I use when, there we go, that one. When do we stop a test? That's an old post. It's 15 years old now. one of the things I use when I'm testing a product and want to decide to stop is I use the pinata heuristic. The first sufficiently dramatic problem says to me, whoa, this is a problem. Maybe I should stop testing right here. Now, none of the heuristics that are listed are in that blog post. It's the very latest thing in the chat at the moment. None of those heuristics are deterministic. We do use our guts. Every decision to stop testing is based on a feeling and not really a fact. It's an assessment of a whole bunch of factors wherein we say, we'll stop testing when we've reached a point of diminishing returns, of diminishing value over increasing cost. That makes sense. There are a lot of facts that we can use to influence that decision, but that decision is always made based on an assessment, and it's usually also based on a social assessment in collaboration with our clients. But a really good heuristic for stopping testing is, I see a problem here that matters, and I'm going to say that this problem is sufficiently bad that it doesn't matter what the statistics end up in. If there's a chance of this, I'm not. I'm going to stop testing, or at least pause testing, and highlight this risk to the client. Ask the client how they feel about this. Victor asks, what are your thoughts on using other AI tools models to assist in testing and evaluation of an AI-based product? Go ahead. But there's something you've got to be able to recognize, and that is if there's an unreliable element in your tool set, then you've got to be able to notice when the tool that you're using is being unreliable and when that could harm the assessment that you're trying to make of the product. So, it's like one thing you could say is, well, if any kind of oracle works like this, if I see something that causes me to suspect a problem in the product, maybe the product is wrong, but maybe my oracle is wrong too. Fair enough. But when they agree, when one oracle says, oh, this looks okay, and another one says, this looks, or when the product does something that looks okay, and my oracle says, oh, I'm not noticing any problems here, the oracle can fool me by not shining light on a problem that is there. That's why we have to diversify our oracles. That's why we need a wide variety of means by which we recognize a problem. Now, in rapid software testing, there's live classes coming up in Copenhagen in the fall. In rapid software testing, we say we recognize problems by identifying inconsistency with explainability, with things that exist in the world, with history, with an image the organization wants to project, with claims that people make about it, with comparable products, and that is the AI tool or model. That's one instance of that comparable product heuristic. With user desires, or what users would want from the product. We recognize a problem when the product is inconsistent with itself, when the product is inconsistent with its intended purpose as evinced by the designer or the developer, or when the product is inconsistent with statutes, laws, regulations, protocols, standards, and so on and so forth. All of our oracles are fallible. They may fail to point to a problem. That's why we need to use a diversity of oracles. If we use AI tools to assist in testing and evaluation of an AI-based product and they shine light on a problem, that's great. But just because they agree doesn't mean that the product's okay. Are LLMs and or AI, how they observe to work with written spoken languages that are not English? There is a fair amount of evidence to suggest two ways in which we got to be careful about languages. One is a very common approach for jailbreaking or working around the restrictions that people try to put around AI output, a large learning model output to make it safer. One way that people get around that sometimes is to translate a query into a language that's more obscure, get an answer and translate that language back into a language that's less obscure. This has been used to jailbreak LLMs in various kinds of interesting ways. The other is that the less training data there is in the training data set, the more opportunity, the more scope there is for certain kinds of incorrectness. Bear in mind, too, that written spoken languages, whether English or not, any kind of text that we're feeding to this thing is just text. It doesn't come with tone the way human speech does. Hitesh also asks, is enshittification getting better or worse? In my opinion, enshittification, one of the words of the year, apparently, coined by Cory Doctorow, look it up, is a terrible, terrible problem. And the terrible, terrible problem that is imminent, seems to me, is that the quality of search results on the web is going to be bad because what the web contains is a whole bunch of AI-generated content. That content is full of errors. It's also very bland and ordinary. And if that gets fed into search algorithms, what we're going to see is decreasing usefulness and value of search. I did a blog post on that, which I will put into the chat. End of search. There we go. The end of search as we know it. All right. And that's a really bad problem. I think Google especially is shooting itself in the foot with this stuff. We had a brief shining moment for about 20 years there where search was super useful and powerful, and then Google started, instead of orienting it towards making it useful for people, Google started prioritizing stuff. Search engine optimization came along and started to distort the rankings of the usefulness of stuff, and it's just getting kind of sad. What are thoughts on AI as a product versus AI as a feature debate? Do you think AI features that are more as helpful tools elevate the future of testing to become a symbiotic relationship between the tester and the AI system? I don't know how to answer that question other than to say this. AI is software. AI is software. It's nothing more, nothing less than software. It's machinery that we feed input to, the input gets processed, and we get output. In that sense, it's no different from any other kind of software. What is different, and what is crucially different, is that the software was not created with a form of intentionality. We fundamentally don't know how it works, and therefore its reliability is open to pretty serious question. In cases, as I've said, where the risk is low and where a human is absolutely responsible for monitoring the output, monitoring the results, and for taking responsibility for how the output is applied, all right, okay. But we cannot abdicate our responsibility for how these things are used and how they're implemented, and I think it is irresponsible for us to promote them when there's a risk that the quality of the stuff can get out of our control. I don't for a second believe that AI is going to take over the world, that machines are going to run us in any kind of fundamental way. But I do believe there's a substantial risk of us abdicating our smarts, of machinery essentially dumbing us down and making us stupid and making us believe that what comes out of a large language model, which is basically just a stochastic parrot, as Emily Bender and her colleagues, Deborah Raji and Margaret Mitchell and that whole crowd of people, interestingly, largely women, are sensitive to the, and women of color especially, are sensitive to the impacts of things that these white tech bros are not. We've got to pay attention to those things, and I'm very worried that LLMs are going to contribute to making us angry and stupid. That's the real risk I see of them. Well, that seems to be the end of the energy for questions. I thank you all so much for your continued attention. It's very gratifying. And I encourage you all, go out and look at this stuff critically. Go out and look at this stuff as investigators. Go out and double down on your testing skills, because finding problems in things is how we start to address those problems, and that's how we help our clients and their clients towards a better world. Thank you all very much. Namaste.